All right, we are on video number 3 of a Swift Concurrency playlist, and we have not yet written any Swift Concurrency code. We have not used async and await, so it's probably time to start doing that. So in this video, we're going to download an image using async and await. We're going to just jump right in, we're going to download the image, and then the next couple of videos, we're going to really take a look at the word async, the word await, and some other keywords, of course.
All right, welcome back everyone. I'm in our Xcode project here. Let's right click the navigator, create a new file, and this will be a Swift UI view. Let's call this one download image async. Click create, and let's get coding. What we're going to do in this video is basically jump right into the world of async await, but we're going to do that by first downloading an image using escape enclosures and using combine, and then we're going to do the same thing using async await. I think for me at least, seeing the old and original ways to do it versus the new way makes it much more clear in my mind what pieces of code are the same, what pieces are different, and maybe why we are doing this the new way. So that's what we're going to do. If you don't want the recap of the escape enclosures and stuff, I would say go ahead and fast forward this video, probably 3/4 through it. But if not, it's probably going to be a great recap. It's a great recap for myself, so I assume it's a great recap for some of you guys as well. Again, I'm calling this download image async because in the Swift UI continued learning playlist, I did a download image with escape enclosures and then with combine. So let's get set up here. I'm going to create a view model for this view. We'll call it download image async view model. Conform to observable object. Let's create our state object, private var view model, and we'll set it equal to a download image async view model. Our view model will hold a reference to a published variable called image of type UI image, and we'll set it equal to nil to start. We're going to create a function here that says maybe fetch image, and for 1 second, let's just set it as a system image for now. So we'll say self.image equals UI image, system name. Let's just maybe do heart.fill. And let's set up our view. It's going to be a simple Z stack. We're going to say if let image equals view model.image, and then we'll put that image on the screen. So we're going to say image from a UI image, pass in our image. Let's make it resizable. Let's make it scaled to fit and give it a quick little frame of maybe 250 by 250. Cool stuff, I know. When this VStack appears, we will then call viewModel.fetchImage. Let's click resume. Let's get this image onto our canvas here. Cool. Not very high quality heart there, but I do love you guys. Let's keep moving here, and just like in the last video, oftentimes you're not going to actually do your fetching from the view model. You're going to have another outside class, a data store, an image loader, a downloader, manager. Let's simulate that by creating another class, and we're going to call this one download image async. Let's call it image loader. Why not? And in here, we're going to have a function to then obviously fetch an image. So we'll say func, let's call it download with escaping, because we're going to use an escaping closure in this one, and we'll open the brackets. We're going to call a URL session.shared.data. We're going to look at all of these completions here, and this is kind of the whole gist of this video here. So Apple provides us with the URL session API, and in here we can see that there's a whole bunch of different ways to initialize one. So at the top we have these completion handlers. So that is your escaping closure. That's the first method that we're going to check out here, and we can see that even just the syntax in here, this completion handler, looks a bit different than some of these other ones. After we do this first completion handler method, we're going to then check out the data task publisher. If you've been following my channel, we've done a lot of combine, and that's what these are for. So these are returning us back publishers that we can use in that combine pipeline. The final thing we're going to check out is actually what's grayed out down here. And we can see the async keyword down here. And these, you can see, have a slightly different syntax, but notably that they throw and then return data. So throws, one of those keywords that we used in the last video. Obviously, async is a new keyword that we're going to check out at the end of this one. But before we get to this, let's look at how we are doing this without the async keyword. So how we do it with just a regular completion handler here. So I'm going to look for this one with a URL and a completion handler. We got to pass in a URL. So let's create one up at the top here. Say let URL equals URL from a string. And I don't have the string yet. I'm just going to explicitly unwrap it. I know that's not safe, but we're going to do it for this video. All right, and the URL we're going to use is actually from pixum.photos. It's a free online API. I'm just going to take maybe this one just to get a square random image. Every time you hit this API, you just get like a random image back. Super convenient. Let's put that in here, and let's then pass in our URL. And now we get this completion handler, and this completion handler is what we really want to point out in this method. When we use these escape enclosures, we have these handlers, and then we have to kick back these handlers outside of this function as well. We're going to do that in 1 second. So let's click enter here. This will be our returned data, our returned response, our returned error. Just to iterate to you guys one more time, this line of code executes as soon as we call the function. This block of code executes when the data comes back from the server. So there could be a bit of time between this, and that's why we have these closures, right? Because it's asynchronous code here. To kick off a data task, you just have to call resume to make it start, and then let's just handle this response. Firstly, let's check for data. So we'll say guard. We'll say let data equals data. Let's also try to convert that data to an image. We'll say let image equals UI image from data. Let's also check that the response is good, but this response is a URL response, and we really want to check if it's a HTTP URL response. So we'll say let response equals response as an HTTP URL response. And then inside that response, we can then check the status code. So we'll say response.status code is greater than or equal to 200, and with a double ampersand, response.status code is less than 300. This is just your general HTTP response codes. You can Google that. It's not Swift specific. And then we'll say else. So if we fail this guard statement, we then want to close out of this function. So here we'll just return for a second. If we do get this image, we then obviously want to kick back that image back to the application. So how do we do that with escape enclosures? Well, we pass our completion handler outside of the function. So up here we'll call completion handler, and that will be of type, and it's going to be a function that returns void. Another way of writing void is just open and close the parentheses. That's probably more common, so I'll leave it like that. But inside this completion handler, what do we actually want to send back here? So we want to send back the image, of course, and maybe we want to maybe an optional error if there was a problem. So here we'll say image of type UI image. We'll make it optional in case we can't get it, as well as error of type error. We're going to get a quick error here in these completion handlers. As you can see, function types cannot have argument labels. Basically, we just need to add the underscore here for the public name, and the image will be the local name. So now we have our completion handler, and we can call this completion handler whenever we want inside this function. So if we are getting an error here, we're going to call our completion handler, and the image, of course, will be nil, and then we can maybe pass back our error. It's the error that's coming from here. But if it is successful, we can then call our completion handler. We can pass in our image, and the error will then be nil. We get one final error that, of course, escape enclosure captures non-escaping parameter. So basically this completion handler can be used inside this function, but it can't be used outside the function. So how do we escape back outside? We mark it as at escaping. I have a whole video on at escaping, and if it is confusing to you, but this should be the familiar part of this video, because in a second we're going to get to the new stuff. So let's call this function from our code now. So down in our view model, let's get a reference to our image loader. So we'll say let maybe loader equals download image async image loader. And then in our function, we are going to call that new escaping closure. So we're going to call loader dot download with escaping. We get our completion handler, and you can see this image error is exactly what we put up here. We're going to click enter on that, and then we're going to get our stuff back. Now for this video, I don't really care about dealing with the errors, so let's just check if we get that image. We'll say if let image equals image, and if we get the image, let's update this image. We'll say self.image equals image. Now we are good developers, and we know that this is asynchronous code, and by calling self here, we are creating that strong reference to this class. So we really want to keep that a weak reference, and then we can make the self basically optional. Have yet another video on weak self if it is confusing you still, but that's not what we're worrying about here. So let's resume this, let's play this, and bang, we got our image already. That was super fast. Running this on the canvas, we can't see any errors, but having done this many times in my life, I do know that we should probably be getting an error here. I would ask you guys to pause this video and try to figure out what the error might be. So when this loads, you guys should see, I think the image will still load, but we're going to get this purple error. Publishing changes from the background thread is not allowed. That is the error. And that's because when we call these URL sessions, they actually run on a background thread, and we need to switch back to the main thread before updating our UI. So in here, we can then first switch back onto the main thread. I actually noticed that this image is optional, so we don't even need to really unwrap it here. We could have just left it kind of like this, and we can actually just dispatch queue.main, meaning the main thread, async, and then we are back on the main thread. So now we can run this and not get that error in our code. Awesome. Awesome. So this is how this is kind of the first iteration of asynchronous code in Swift. We use escaping closures, we use these completion handlers, and we kick them back out. Now we're going to download using two other URL sessions in this video. All three methods are going to return us back data response error, and we're going to handle a response the exact same way. So because of that, I don't want to focus on rewriting this code. Let's extract it to a function. So up here, I'm going to create a func, call it handle response. Let's see here. We need to pass in the data of type, I think it's optional data, as well as response of type URL response. Let's take this guard statement here, paste it up here. Let's make this function return the image. So this function should return a UI image, and just for simplicity's sake, we'll make this one optional. So if we have the error, we're just going to return nil. So down here in the code, let's just say maybe let image equals handle response with the data, the response, and then we can call completion handler on the image and the error if there was an error. So I will delete this. Call to method handle response requires explicit use of self yet again, so that's creating that strong reference. Let's keep that weak. And now we are writing good code. Again, this line of code is not what we're worrying about in this function, but the rest of it is dealing with these closures and these closures. This is basically what we want to avoid by using our new handy dandy Swift concurrency stuff. Before we get into Swift concurrency, I want to run you guys through what this looks like using Combine. So let's create another func here called download with Combine. We're going to call URL session shared.data task. Look for the publisher for the URL, and we'll pass in our URL here. We are then going to map that response, and we can see that the data we're getting back here, data and response. So that is the same keywords that we have in this function here. I did that. I already checked it before we made this video. So we'll call handle response, and it's implied, so we can just keep it like that, nice and clean. We then want to erase this to any publisher so that this function can return us any publisher. And we don't have access to any publisher because we have not yet import the Combine framework. Any publisher. Just like the result in the last video, any publisher is generic. So you need to declare the type and the error type. So the error is just going to be a regular error. The success will be a UI image. We'll just keep it optional for now. We're going to get one quick error that basically the error coming back is a URL error, and the error that we marked here is a regular error. So we can just map the error from a URL error to a regular error, which is the error itself. They conform to the same protocols, so we'll just keep it like that. Again, that's not what we're focused on here. Let's call this from our code. So coming down here, instead of download with escaping, I'll comment that out. Let's call loader.download with combine, and we get that nice any publisher back. This, we want to then sync the value. We get the completion, which we're not going to worry about. I'm just going to leave that blank, and this will be our returned image. And then in here, we're going to do the same thing that we did here. So we want to switch back onto the main thread and set up our image. Let's also keep our reference weak. Finally, we want to store this somewhere, so we'll call store our cancellables. We need a set. So up here, let's create our var cancellables equal a set of any cancelable, and let's store them in that set. I'm going to build and run this one more time. Everything is working perfectly. This is actually not the Combine way to switch back onto the main thread. So one of the key differences from the escape enclosures to the Combine is that we can use these pipelines. So we can then actually just receive values on the dispatch queue.main. We don't need any options, so I will just delete them. And then we don't actually need that dispatch queue here. And we can build and run. We'll see that we don't get that purple error because we are still receiving on the main thread. So this is kind of what I wanted to point out here in this video is like, this is one way of doing it and this is another way of doing it. Both of these are valid ways to do it and are good ways of writing code. But what we're going to do next is using async await, which is probably a sleeker, more elegant, and probably even more efficient way to write this code. And towards the end of this video, I'm going to start highlighting some of the major differences. So now that we did escape enclosures, we did Combine, I think it is time to actually jump into async await. And I promise the rest of this playlist will actually be async await stuff. This is kind of just the intro. Let's create a func called download with async. Open close parentheses, open the brackets. We're going to call URL session shared.data task. And we're going to look for the ones that are actually grayed out right now. And the reason they're grayed out, they have this async keyword here. And we can see it at the bottom. The compiler is literally telling us that we can't call these functions right now because we are in a context that does not support concurrency. So this is just the introduction to Swift Concurrency. And without really diving into this, this is kind of one of the major superpowers of using Swift Concurrency. There are basically tons of checks that are built into the compiler that most of the time will force us to write our code in very specific patterns that are safe to do and safe to write. So for example, here, if we were to call this and we are not in a context that supports concurrency, our code is actually not going to compile. We can't even run our app. But fortunately, it's actually a fairly easy fix. So what we want to do is mark this function as a function that does support concurrency. And the way we do that is literally marking it with the async keyword. So now if I call data here, you can see that those asynchronous calls are no longer grayed out. We're not seeing that error message at the bottom here because we are in an asynchronous context. Let's use the URL completion here from URL. And the URL will be the same URL that we've been using. The delegate we're not going to worry about. And we can see that the return type, this is an asynchronous function that throws, which we learned in the last video, and returns us a tuple with data and response. So I'm going to set this equal to data and response. And as we learned in the last video, if functions throw, that means we have to try to get their response. So we will add the try word here. The only major difference from the sample in the last video and this one is the error message we're getting right now, and it's that this expression is asynchronous but not marked with await. So the await keyword is basically a suspension point on the task, and we'll get into that and I'll get more into that in the next couple of videos, but in layman's terms what it means is we are literally going to wait for the response. So when we call this URL session, it's going to execute immediately, but the response isn't going to come back immediately. It's going to come back after it goes to the server, gets that data, and then comes on back. And so if we had left our code like this, it would look synchronous, like it was going to happen immediately. But if we add the await keyword, we are notifying to the compiler that we might have to suspend the task at this state right here, waiting for the response, and then continue. We're going to get these same errors that we got in the last video. Errors thrown are not handled. So that's because we want to do our tries usually in a do catch block. So I will create that do catch, put the try up here. Let's catch the errors. So if we get an error from our catch block, let's actually just throw it back out of this function as well. So we will throw the error that we are getting. And again, to mark this function as something that can throw an error, we mark it as throws. But if we do get the response, we then want to obviously handle the response and return back that image. So we'll say let image equals handle response from data and response, and then return back the image. And of course, we need to mark this function as a function that returns an image. So return UI image, and I think it is optional just for this sample here. We had optional UI image here. And I can make this a little bit cleaner actually. Just put this on one line, and there we have it. Our first function with async and await in it. Download with async. But of course, we haven't actually called this function yet. So let's come down to our code. Let's comment out our combine code, and let's do one more. I'm going to actually fold all this up with the /* and then */ fold it up with the option command left arrow. Again, you can also fold by using the code folding. And let's call loader dot download with async. And again, we get that error that we had before. It's grayed out, and that's because we're not in a function that supports concurrency. So I'm going to call this, but we want to mark this function as supporting concurrency. How do we do that? Well, we add the async keyword. We then have to try to get the response here. And as I showed you guys in the last video, sometimes you don't really care about the error. And if you don't care about the error, you don't really need to do a whole do catch block. You can just optionally try. So what we're going to do here is say if we're going to say let image equals try loader.download with async. And then this image will then be optional. And then we can call self.image equals the image. We're getting that same error that we got before with the await keyword. That's because this download with async is an asynchronous function. It has potential for taking some time before returning back to our code. So what that means is we need to await. Now every time we call this await keyword, it is marking our code as a suspension point. So there could be time executing this and then actually returning this result. Now, most of the time, even though we're calling await, it happens more or less instantaneously. pretty immediate, but there is no telling how long it's going to take. This await keyword does not change whether it's 1 second or 1 hour. It's just we are waiting for the response whenever that comes. So this is awesome. We're going to come down to our code here, and we have one final error, right? We are calling an asynchronous function, but we are not in any kind of function that supports concurrency. So so far we've just marked functions as asynchronous, but the question is, if you can only call an asynchronous function from an asynchronous function, how on earth do we ever get into a context that does support concurrency? And the answer to that is by creating or starting a task. And then we can call our functions inside. And this function, yet again, is asynchronous, so we need to await on it. Now there is a lot going on with this task. It deserves its own video, and I'm going to do an entire video on it. But for this video, all you guys really need to know is that we enter a task to get into that asynchronous context. So we get into it, and then we can use our async and await inside that task. I'm going to build and run. I'm going to build this to the simulator quick. We should get that image working. So we see that image, which means our code is actually working, but we have that final error where we are publishing changes from a background thread. Now it's going to be pretty tempting here to think, oh, we can very easily do a dispatch queue.main.async and switch back onto the main thread the same way we did it up here. And we could do that, honestly, but we should not do that. So once you are in this asynchronous environment, we then actually want to start using actors. And actors are another whole big topic I'm going to cover later in this playlist. But there is one actor that's already created for us in every project, and that is the main actor. The main actor is more or less the main thread. So the way to switch back onto the main thread using the async await keywords is actually calling main actor.run. And we will run this code then on the main actor. So I can put this in here. Now, switching onto the main actor is more or less switching onto the main thread. And depending on where our code is before that, it might be a suspension point as well, where we have to wait to get onto the main thread. So yet again, we got to use this await keyword. Again, using these await keywords could mean we're waiting a lot of time, but most of the time we are waiting and it's happening basically instantly. So here we're going to wait to get back onto the main thread, but realistically that's going to happen pretty instant. I'm going to run this one more time and we should now get our code without any errors. Awesome. Again, guys, I'm going to cover task in its own video. I'm going to cover main actor and other actors in their own video as well. But I wanted to just spend this video to introduce you guys to async await. So we can see up here, basically, here's kind of the whole gist of the differences between the original way that we would write asynchronous code in Swift using completion handlers and escaping closures. Then more recently, we learned combine. We could just use these nice publishers. And now we have asynchronous code, which looks much more like this. The really big things to point out here is that when we call this download with escaping, we have to manually create these completion handlers and then pass our data back. And if you were with me in the last video, passing an optional image and an optional error is okay. We kind of discussed this in the last video, how this is okay, but then when you get this data, you kind of then have to like figure out, is this image legit? Is this error legit? And you have to deal with that. Versus when you're using these asynchronous and throws keywords, we know this function here is either going to return us the optional image or it's going to throw us an error. And so this ends up just being much cleaner to work with. And it's also much safer to write, because even if we just think about reading the code, right? When you read this up here, unless you are very familiar with these closures, it's kind of hard to tell that this is asynchronous, right? We're calling this data task here, but this closure is actually not happening immediately. This is, if we had the await keyword, it would be right in here. It would be between this call and this result. And that's why this is a separate closure. Now, obviously, we can't use the await keyword here, but so this call is this call, and these returned pieces of data are these returned pieces of data here. The two biggest things to call out here are when we have these closures, we have to manually manage these references. So we made our reference to self weak here, but you'll notice that when we did this in the asynchronous context, we didn't actually have to add weak self anywhere here. That's one big benefit. Second benefit is if in this function we forgot to maybe call a completion handler, so maybe just on accident, right, we made some mistake in our code, we never called the completion handler, that could lead to bugs and other issues in our app. Whereas here, if we forgot to return something from the function, our function's not even going to compile. We're going to get an error that says you got to return something from this function. So just by getting these notifications from the compiler makes us write better, safer code, right? We can't call this without the word tries, without the word await. If we want to throw an error, we have to use the word throws. If we're calling asynchronous functions, we need to be in an asynchronous environment. So there's a lot of small rules here, but at the end of the day, they actually help us out tremendously as developers. So there you have it, guys. 3 different ways to download an image using escape enclosures, combine, and async await. In the next bunch of videos, we're going to dive deeper into async and await. We're going to dive deeper into tasks, and eventually we'll get into actors. Hope you guys are still with me. A lot of new stuff to come in the next couple videos. Thank you for watching. As always, I'm Nick. This is Swiftful Thinking, and I will see you in the next video.